Welcome to Physics for Class Waves and Optics. The group members in Group 1. Class objectives and rules.
Today's discussion was all about interference and coherent sources.
Interference of light waves can be either constructive interference or destructive interference. Constructive interference takes place when the crest of a wave falls on the crest of another wave such that the amplitude is maximum. These waves will have the same displacement and are in the same phase. Number 2, the destructive interference. In destructive interference, the crest of one wave falls in the throw of another wave such that the amplitude is minimum. The displacement and phase of these waves are not the same.
The principle of superposition of waves. According to the principle, overlapping waves add algebraically to produce a resultant wave, or net wave. In other words, when any number of waves met simultaneously at the point in a medium, the net displacement at the given time is algebraic sum of displacement due to each wave at the time. For example, let us consider two waves traveling together along the same straight string in opposite direction. They met and passed through each other and move on independently as shown in figure. Each picture depicts the resultant wave formed in stream at a given instant of time. The principle of superposition of waves implies that overlapping waves do not in any way alter the travel of each other. Let's focus now in the monitor for the simple mathematical equation.
types of interference. The first one is the constructive interference. The second one is destructive interference. Constructive interference, it is a type of interference where the two interfering waves have a displacement in the same direction. The constructive interference is observed at any location where the two interfering waves are displaced upward. And it is also observed when both interfering waves are displaced downward. Interferential generators produce mixed currents within tissue. Constructive interference refers to the concepts that when two electrical currents are perfectly in phase, the amplitude of the combined wave will be equal to the sum of both waves. For example, the generator 1 produces a wave of 400 Hz, while the generator 2 produces a wave of 400 Hz. The two waves together are perfectly in phase. The resultant waveform that is produced from generator 1 and generator 2 would equal to 800 Hz.
This wave is a destructive interference. It is a wave that destroyed each other. When this overlap, 1 and 1 is 0. 0 and 0 is 0. Negative 1 and 1 is 0. These two waves are gonna add up nothing. That's why it is called destructive interference. There are applications in this. Imagine you're sitting on an airplane and you're listening to the annoying roar of the airplane engine in your ear. It's very loud and annoying, so you put an headset or headphones in your ear. This sound wave coming in and they cancel off that sound by sending in their own sound.
What are the two types of light interference? So we have two sources of light, which is constructive and destructive interference. So what is constructive interference? Constructive, it occurs when the maxima of the two waves are added together. The two waves are in phase, so that the amplitudes of the resulting wave is equal to the individual amplitudes. When two waves come close to one another, their effects add together. In the picture below, for example, if the crease of the two or more waves are in step, which the color is yellow and magenta, if waves stop are shown in the picture below, they can combine into a larger or more intense effect, which is red wave. This is known as constructive interference, in which two waves interact in such a way that they are aligned each other. So let's proceed on the next topic, which is destructive interference. What is it? It occurs when the maxima of two waves are 180 degrees out of phase. A positive displacement of one wave is cancelled exactly by a negative displacement of the other wave. The amplitude of the resulting wave is 0. For the example below, if the crease of one wave met the value of another yellow and magenta wave in the bottom, they cancel each other out of the red wave bottom. When the light wave cancel each other, the result is darkness, and this is called destructive interference.
Wave interference occurs when two wave sources overlap and when the equilibrium point is in the center, where it is 0. The total wave will be determined by adding up contributions. Wave 1 plus wave 2. 1 unit plus 1 unit is equal to 2 units. 0 plus 0 is equal to 0, and negative 1 plus negative 1 is negative 2 unit. There will be a big cosine looking wave. As you can see, this wave is constructively interfering, and we call this constructive interference because the two waves combine to construct a wave that is twice as big as the original waves. Wave source 1 starts at the maximum and wave source 2 starts at minimum, as we call this the pi shifted. When we overlap wave 1 and 2, we perform the same analysis. 1 minus 1 is equal to 0, 1 minus 1 is equal to 0, 1 minus 1 is equal to 0, and so on. We can see a straight line drawn up in the middle, as we call this the destructive interference, because these two waves destroy each other.